Welcome, folks. Thank you for joining us today. My name is Jing Yu, Managing Director of Fortress Power. I've been in solar for many years, obtained my electrical engineer degree in Germany and started my solar career there. Like many of you, I love renewable energy. It's also my honor to have Brian from Darfon. He is a product manager at Darfon with me today. Brian's going to cover the hybrid invert part. Brian actually also operated a solar installation for many years, so he knows very well what challenges you guys are facing. He also co-designed Darfon Hybrid Invert H5001, which we're going to talk about a lot about that later.
Well, co-design, that's pushing it. The designer's in Taiwan, but I'd like to think I've had some input.
Good. Today we're going to cover three topics. We're going to start with a growth opportunity and show you how we can help you to grow the business. And then I'm also going to touch about a sizing tool that we have developed can help you to size up backup systems. And Brian is going to cover how to install and how to program the hybrid inverter. So let's dive into the presentation. Energy storage is becoming one of the fastest growing industry globally. Here in the US this year, the market will double, as you can see, and it's expected to grow 7 times in next 4 years. Sorry about that, and to become a $3 billion revenue. It's a tremendous opportunity for all of us, and very encouragingly, non-utility sector will constitute over 50%. So the pie is large enough to be shared by small and medium installers. Even though we're on the growing path, we're still facing some challenges. As you can hear some statistics I would like to share with you. 74% of homeowners are interested in home energy storage. However, only 14% receive quotes for solar plus storage. The reason is, we think installer, they don't know how to sell it, they don't know how to design it, and equipment are kind of expensive and it's really hard to install, so it's a lack of the training. Well, the good news is 50% of those who receive quotes actually become buyer. So the message is here that, for solar contractors, you really should quote storage. If somebody asks for solar, please also give them a quote for storage. So today, Brian and I are here to show you an affordable, easy to install solution to help you to grow this energy storage business. Brief introduction of both companies. Fortress Power, we produce lithium batteries. We're headquartered in Southampton, Pennsylvania. I think, Brian, are you just second here? Yeah, Brian has access to my presentation as well.
We're located in Taiwan as a corporation. I'm still located in Mountain View, California. So we have local support and local sales support from within the United States.
Good. I appreciate that input. Okay, so next slide, I'm going to start with the technology difference between lithium phosphate and lithium and nickel manganese cobalt batteries. There are many chemistry available in the market, but those are the two that are widely commercialized and available here in the market. So we use lithium ferrophosphate, short term LFP. Companies like Tesla and LG Chem, Panasonic, they use nickel, manganese, cobalt. So the short term is NMC. Why we choose LFP over NMC? It's safe, and because we don't use the cobalt. As you probably know, cobalt is a very temperature volatile element, and it can be also fully recycled. LFP batteries. It has a wider operating temperature. Delivers substantially more cycles, so we guarantee up to 6,000 cycles versus the NMC batteries are less than 3,000 cycles. Our battery has also higher surge power, also enables you to power large appliances. The degradation rate of LFP battery is also less than NMC. So you're probably familiar with degradation, a term, of solar panels. So take all those benefits in consideration. For energy storage, LFP is the perfect solution. Here's a specification about our current battery. As you can see, we offer large battery bank, 10 and 15 kilowatt hour. The maximum charge and discharge are 100 amps. The battery also provides 200 amps, equal to 10 kW surge power. It's designed to work with the 48 volts inverters and chargers. Very compact. It's heavy duty, so it's very robust. Can be fully discharged. You can get the maximum usage power. It comes with a 10 years warranty. And also we allow you to, stack 2 in parallel to 1 inverter. And also one thing I like to highlight that our batteries, unlike the lead acid, really look very sleek. It looks like a home appliance. This is our next generation battery. Here we add some features to that. First of all, we have a display that in the middle that can show the voltage and also state of charge. That way, give the homeowner more accurate information about the state of charge of the battery. And also, we make this be more compact. You can see it's the weight is less because we upgrade the battery cell. There'll be more, has a higher power density. Also come the same 10 years warranty. And the beauty is allows you to parallel 5 batteries to 1 inverter. So now you can get up to 75 kW. We are producing the unit. It's going to be on the way soon and expect to be delivered here in late September in our Southampton office or warehouse here. Okay, here's a list of battery inverters that we're compatible with. Well-known brand Darfon, Alpac, Schneider, Magnum, SMA. This is also something you can find on the website as well. I'm going to focus today on Darfon because I personally really like this inverter a lot, and that's many good reasons for that. I'm going to touch some of this, and Brian's really going to show you why it's the best solution now available on the market. This is how the inverter looks like. Very brief. It integrates PV inverter, charge controller, controller, communication, distribution box, and built-in auto transfer switch in all one unit. It's as simple as like you install a traditional PV inverter. That makes your life much easier. Here is a picture of a 5 kW hybrid inverter with our 10 kWh battery bank here. That shows you how compact it is. Couple of key features of the unit. The continuous AC output is 5 kW. I believe this also increased now to 5.5 kW. Brian can confirm that later. And also allow you to surge to up to 7.5 kW for 1 second. It has a built-in auto transfer switch. Switch times only 20 milliseconds. We have a unit installed here in the office. You don't see any flickers. It's very, very smooth. Supports 120 and 2040 split phase. The continuous AC output is 21 amps here, but actually, if you to be more accurate, it's 23 amps. The battery input is 48 volts. I do want to emphasize that, for Java inverter, if you still have a client that, prefer use lead acid, the inverter, works with also many different battery types. It does give you flexibility. I know some clients prefer lead acid, or there's some jurisdiction like New York City, you cannot install lithium at the moment, We provide 6,000 cycles. The battery capacity is 10 and 15. You can scale up to 75 kilowatt hour with our generation 2 battery, so give you large enough power capacity. Each inverter can hook up to 6.5 kW array. And also very good news that the inverter is going to allowed to be stacked in 3, so you really can get to 15 kW. I put here July here. I'm sorry for the mistake. Actually, it's in September, and the Darfon is going to release this officially, at SPI. The solution we offer is all-in-one. It supports backup, time of use, off-grid, and self-supply. You have one inverter manages the PV and the storage. What does that mean? It's more efficient, and of course, the less components you have, then you have less, failure points. So here's a comparison of different backup options. As you can see that thanks to the long life cycles of lithium, so we can support backup power, time of use, self-use, and off-grid. The battery can be fully discharged, so you can get like a 10 kW battery. You really can get useful power of 10 kWh. The lead acid, you can get 5 kWh. We guarantee up to 6,000 cycles. It comes with 10 years warranty, no fuel cost, no maintenance. And if your system is powered by PV, you can get 30% ITC and also some local incentives as well. To lead assets, life cycle 500 or 1,000, warranty of course much less, and a still good amount of lead assets requires maintenance every 6 months. The third option, generator. Of course, I'm not a fan of a generator. It creates pollution, and it's very expensive to run. My neighbor, they have generator, and it always drives me crazy in the evening. In the night, they keep the generator up and running, and I, just have a hard time to sleep. After we compare the features and benefits, let's also take a look at the cost comparison. So we conduct a cost analysis of a couple of 3 different projects. Let's start with Fortress and Darfon solutions. It costs to a homeowner about $12,000, including material and installation costs and some reasonable margin for the installers. And lead assets, for this particular job, we use the Outpack inverter and an 18 kWh lead acid battery to get the same, 9 kW usage power. We set up 90% of double discharge for our lithium. So that's why he has 9 kWh usage power. Good. So the cost of the lead acid system is about $13,600. That also including the cost from the battery rack, which is also very expensive. So if you are in California, so you could be entitled for S-chip incentives. So it takes $3,150 off. And then you can, if your PV is powered by solar, of course, you get 30% ITC. So you take $2,655 off. Your net of pocket is $6,195. Divided by the 6,000 cycles, your cost per cycle is $1. And if you are not live outside of California, no local incentives, just at 30% ITC, your cost per cycle is $1.40. And let's take a look of the lead acid systems here. You can see that with S-chip incentives, 14.3, and without S-chip is $19 per cycle. So that is, big differences. That's why if you need mini cycles, lithium is the perfect solution. And generator, no incentives, and of course, it's expensive to run the generator. Here for a typical house in the US, we talk about $50 to $100 a day. And of course, a lot of places, when you're a storm, you don't even have access to fuel. Good. Here's how we compare with some well-known brands here. Let's start with configuration here. We offer a DC coupled solution. There's one inverter, manages PV and storage. So it's at least 5% more efficient. If you consider, that system should supposed to be there more than 10 years, or even longer, 5% makes huge, big differences. Okay, good. So both Fortress and Zonin use the safe chemistry LFP. Others offer NMC batteries. We provide 6,000 cycles. NMC batteries usually less than 3,000 cycles. Zonin, of course, claims they can do 10,000 cycles. If you take 1 cycle per day, that's usually how you design a system for, off-grid, time of use, or self-consumption. So in order to exhaust the battery, it takes 30 years. The question here is, can the battery last for 30 years? I have never heard about any lithium battery that is, proved to be last for 30 years. Of course, if you look at the price of ozone, it's extremely expensive. I think they need to be justified to put some cycles that they, make that you feel good about paying that high price. So our large factory capacity that, enables us to offer the most competitive price, just like mentioned, Darfon as well. Darfon has, 4 factories just in China. So capacity is the way to drive down the cost, right? That's no secret. Of course, with the low cost and cycle, we offer, the lowest cost per cycle. That's the benefit for your clients. And having the battery and power electronics separate, it makes the maintenance much easier. Tesla and Zonin have battery and inverters in one cabinet that prevents you to accessing the components, the battery inverter, if you have to diagnose some problems. So overall, we offer the best solution. That's the conclusion. So here's a quick summary of our competitive advantages. Safe, very competitive price. We know in order for you to be successful or for energy storage to be successful, we have to continue to drive down the cost. The clients can take the lowest cost per cycle. It's all-in-one solution, supports backup, time of use, self-consumption off-grid. DC coupled solution is more efficient, less component. That means also more efficient. And it takes really less than 60 minutes to integrate storage to a PV system. So of course, in the beginning, it takes longer, but once your crew is getting used to it, it's really very quick. And of course, having the battery and power electronics separate makes the maintenance much easier. Good. I'm also going to spend a little bit of time, but I'm not going to dive too much details because otherwise it's getting too long about this energy storage sizing tool. So we've seen many installers having problems to size up a prop energy storage for clients, particularly for backup. We've developed a sizing tool to be shared with our authorized dealers. So this tool includes 5 steps. So you have 5 steps, to complete a quote for your clients. You start with sizing the PV array, and then estimate the average daily PV production, and select critical load circuits, and then you calculate what the daily usage is. Based on that information, then you can decide what the proper battery bank size for your customer. Let's begin with the PV array sizing. So you enter module information here: wattage, VOC, VMPPT, temperature coefficient, record load temperature, and put your quantity here. The sizing tool will automatically calculate the string VOC and the string VMPPT, and of course the total PV array as well. The nice thing about a Darfon inverter is that it has 2 independent MPPTs, so it allows you to put different module quantity in each string. Like here, you have 9 in one string and you have 8 in another string. As next, let's take a look at the daily PV production breakdown by month. We're going to focus on the best months and the worst months. The best months for this particular project based in New Hampshire, you can see that the average daily production in July, which is the highest, it's around 24 kilowatt hour. And then in December, it's around like a 10 kilowatt hour. That's in New Hampshire. If you are in the South and in California, the production is much higher. I expect 30, 40% higher. Okay, good. Here, the core of this tool is building up critical load circuits, to meet your customer expectation, but also tell them to be realistic. This is a tool that really can help you to do that. So we've categorized all commonly used appliance and built in the starting wattage and the running wattage. So starting wattage, running wattage is all built in here. So you just need to select category and item here, quantity. Some of the appliance, we also build in the hours of operation per day. For instance, like in this first item here, the refrigerator, if you're Energy Star rated, the real operating hour is 8 hours. And then it calculates automatically. It consumes like 1,600 watt hour a day. We select here 10 circuits. That is typically, when you need for backup. The total consumption of this house is around 12 kilowatt hour, 12.5 kilowatt hour. On the bottom, the tool also calculates the total surge power and total running power, make sure it's under inverter's threshold. So now the last step is to size up the battery bank. Here, this is the number that took from the previous page. Again, the total consumption is 12.5 kilowatt hour. As minimal, we recommend that you select a battery bank that helps the client to last for a day without any PV. So here we select their LFP15. It's a 15.36 watt hour. 90% depth charge is like 13.8 kilowatt hour available power. So it can help the house to last for a day. And then now, look, in December, if you still remember, that has the lowest daily PV production. It's around 10 kilowatt hour. Of course, it's not even enough to charge the battery in this case. But again, it's in New Hampshire. So in this case, the homeowner knows, okay, in winter, I really need to be cautious during the day because I want my PV charge the battery and I can use them for the night. In summer, the production is 24 kilowatt hour. So now your clients know, okay, during the day, I can consume more if I let the PV charge the battery, but then excessive one, I can use it. If I don't use it, the inverter is going to basically curtail the PV production. So this is something that you can, it's not perfect tool, but this is a tool that helps you to engage a conversation with the clients and, tell them what to expect. Good. So that's my part. I'm going to switch to Brian. Oh, I still have one page here that I'm sorry about that. This is actually for time of use application that if you have, clients that want design system time of use, this is a little bit more complicated. So we have a third-party tool that we can use to run a report for you, a financial report. If you give us a monthly electrical bills, the end-of-our data, bring button data, or, like import utility API data, those information that we need, then we can do that for you. Okay, and this is a slide here, a dealer benefit here. It's really easy to become our authorized dealer. Fill out applications available online. We can send to you. We can, product training and design training. And of course, we offer a lot of dealer benefits like sales, marketing support, great, discount. We keep a good stock here to make sure that we can ship to you right away. Provide technical and product training as well. Good. So Brian's gonna, dive you into the installation and the programming.
Okay, great. Thank you so much, Jing. I appreciate. Yes, it's transferred over to me. I appreciate the introduction, and now we're going to go through the nuts and bolts, how to install the system. Bear in mind, I'm going to go through the hardware installation pretty quickly. I may skip some slides. All of the slides will be present if you want to download them and pick them up. But the reality is the hardware installation is pretty straightforward, and if you've installed a standard string inverter, you can install this. What I want to spend more time on is towards the end where we have configuring it and then setting AP registers to the more common areas that may need to be changed. Okay. There we go. So I'm sorry, it's a little slow. It didn't respond. Primarily, it comes in a cardboard box. Sorry about that. And the important thing about the cardboard box is your serial number is on the outside on a label. Two things here. One, your serial number that you'll need to set up the warranty registration. And two, you'll notice that the warranty, the cover on the box says model number H5001, but the label on the inverter, the H5001, says model H5000. The inverter is an H5000. That's what you create your plans for. That's what you submit to your local building department for inspection. It's an H5000 inverter. An H5001 is simply an H5000 with a distribution box on the bottom that we'll go to very shortly. But all plans are done, submitted with an H5000 inverter, and that's the label the inspector will see. Here's your box. It's a picture of what the inverter looks like. You know, inspect for possible damages. You know, when you get it and receive it, that's when you assign problems for damages. Don't do it after you've installed it. It's too late. This is the distribution box in the bottom. This is what differentiates between an H5000 and an H5001. Note it's no power in the bottom. The inverter is an H5000. But in this box, we've got the PV switch. That's your disconnect. We've got your grid tie, your battery disconnect switch, and all the quick disconnects for PV, grid tie, critical load, and generator. Now the generator contactor and control switch is optional. So if you need a generator, make sure you put purchase the option for the generator contactor and control on the order. So here's your PV disconnect, your battery disconnect. Both are on the distribution box, and the special button that switch that turns the inverter on and off. Just a simple rocker switch on the side. That's really an important switch. Remember it. So anytime you're mounting something on the wall, you need to be able to get to it. We've got plenty of knockouts, eccentric knockouts, left side, right side, and the bottom. The one underneath the battery disconnect is much larger, going up to 1.5 inches in diameter, so that you can connect the larger wires. Although with any of the standard batteries, I think the wire size is only number 2, so it's not huge. And that's what I just said. It mounts, simple hanging on a bracket. You mount the bracket. I use Unistrut when I can. It just makes an easier install, accounts for walls that are not flat or not consistent. Hang it, put some bolts in the bottom. We're all done. Again, I'm going through these really quick because I need to get to the bottom stuff. This is the stuff that we need to start being interested in. Your PV1 and PV2 strings, each has its own MPPT. Those plug in on the left-hand side. You put a 3/16 screwdriver or something similar in the top little hole, open up the contactors, push the wire in, take the screwdriver out, it's in. You need to remove the wire for whatever reason, exact opposite. Put the screwdriver in, pull the wire out, take the screwdriver out. So we've got PV, grid tie, L1 neutral ground, L2 ground. Load output, this is your critical load, and you will notice that we have 2 L1s, 2 Ns, neutrals, 2 L2s, and a ground. We'll go into why later. And those are all designed for 8-gauge wire. Then, of course, we've got the generator coming in, L1, L2, and it must be a 120, 240 generator. Can't be anything else. And then we've got your starter circuits for your 0 and 12 volt and external relays. And like I said, you just put a screwdriver in, push the wire in, out it comes. You've all seen these connectors. It's very simple, very quick to install. By the way, if you want to make it even easier, you can get a ferrule. This is a little solid copper piece that sits on the outside of the wire, and crimp it on. That ferrule is designed to fit into these contactors, makes it a lot easier. I've never seen anybody do it in the field, but it is nice. Something to look into. So PV, 2 MPPTs, 10 gauge wire maximum, and don't forget to check your polarity. That will cause problems getting your system started if you reverse the polarity on the inverters. So you install 1, 2, your PV is done. It really isn't much slower than that. Want to make sure your grid is taken care of, but you want to make sure that it's turned off before you start plugging wires in. Again, up to 8 gauge wire, and that's what we recommend. So we L1, neutral, L2, and ground. And that's our complete tie-in for the grid tie. There's a lot of room to work in down here. You've got plenty of rooms. I've got big hands, so I made sure it's got enough room that we can tie things in. It works really well. For your critical load, same thing. L1, neutral. Now I intentionally on this picture used a different set of contacts. Instead of the first contact for neutral, I'll use a second contact. Those are truly parallel. It doesn't make any difference. If you want to land L1, put it into either one. If you want to land L2, put it into either one, and so on. Neutral, ground, and again, you're done. Battery is only a little bit more difficult because it's actually got screw-on lugs. This is heavier duty wire. You need heavier contacts. So there's the negative side where you'll pull off there's a clear cover over it. Pull out the screw, put the lug in, put the screw back on, put the clear cover back over it. Then you've got the positive, same thing. It's a 5/16 lug. So if you're building your own cables, that's what you want to use. And then put the clear over and you're done. Very, very quickly. Nothing here is hard. If you have any questions, feel free to ask later. I know I went through that very quickly, but this is no different than installing a string inverter, except that it's got an extra set of AC wires and 2 battery wires. Now comes the fun part. Setting up the display panel. This is actually kind of cool. On the screen, as you saw in the front picture of the inverter before, you've got 4 buttons under the LCD. Those buttons are defined as enter, escape or exit, left arrow, and right arrow. The left and right arrows work you through various screens or pages, or in selecting a value if you're to configure. Enter is just that. This is what I want to do. Yes, enter. And exit, escape just gets you back out of the mode that you're in. On this LCD, you've got 3 screens, and again, you use the arrows to go through them. Right moves you to a higher number, left moves you to the lower number, and it rotates. So if you're at the first one, which is power flow page, and you want to go to the system settings page, you can go left 1 or you can go right 2. So the first page, power flow page, this actually shows you where the power is coming from and where it's going. You'll note that on the battery, it has arrows on both sides. That's not a typical display. We don't send power both ways. It just shows that it will show you which way it's going, just like on the utility. Is it feeding power back? Is it taking power in? PV array shows the arrow only going into the inverter. We typically don't send power out to the PV array. So we've got the icon for PV, battery and utility on the left. We've got load on the right, and that shows up the little house there. And we've got the error section on the bottom, the inverter in the middle, and whether you're connected to a PC or not in that little icon. It also shows today's date. The total energy which is sent back to the grid is in the upper left-hand corner, and the amount of power currently going to the load. Now the load is handled, depending on the mode you're in, operational mode, either from PV, battery, or utility, and in which order is defined by the mode. We'll go through that in just a little bit. The next page, we start breaking down the power a little bit more precisely. So on the left side, we've got PV input 1, PV input 2. So you can actually determine what the voltage and the wattage coming in from each MPPT directly. That way you can calculate the current. You can see that both strings are working correctly or as expected.
The battery shows the current operational voltage, excuse me, that you're running at. What is a properly fully charged battery is determined by the battery manufacturer, and you can set that value a little later in the AP registers. We'll go through some of that. With the next one down, it's the charging current. Now, it's actually current, not charging current now. We've changed this. This is taken out of the manual. So it actually shows you bidirectionally. Is it charging the battery or discharging the battery? So we just list it as current, and then you can look at the power flow page to determine which way it's going. And then, of course, we've got the load. This is your critical load. This is the part that's managed under battery backup, should you need it. That gives you the number of watts you're currently using and what the voltage is on that back side. So you should be at the 240, 247. This is always load line to line, not line to neutral. So it's always somewhere around 240 volts. The third page is a system settings page. So here you're identifying how the inverter is set up. First is the mode. We've got backup mode, residential, which is self-consumption, time of use modes, and a couple of different variations of each of those. Time of use, and you say the high price duration, that's setting up the time that you're feeding power back, what time you start, what time you end. The next, of course, is just your standard time setting. What's the date and time? The really interesting one, or the one that we want to pay attention to later in this presentation, is the information one, the circle I here. Multi-inverter, Jing touched on the fact that we are offering the ability to stack these inverters. If you're going to be doing an installation with more than one inverter, then you need to turn this from single to multi. In addition, you've got battery type. Okay, this shows as none. That's if you're installing as a string inverter, which you can do with our inverter. You would define the battery type as none. There'll be no errors because there's no battery connected. You also have other battery types, and we'll go through that in just a second. So these are the modes that you can bring it up in. The default is backup. This keeps the battery full and discharges only when the utility grid goes out. Residential, this is self-consumption. So you'll consume from the PV when there's power from the PV. Battery first before the grid. So you'll consume the battery on a grid-tied system down to about 35%. At that point, you'll start taking from the grid because we reserve that much for in case the power goes off later that night. We reserve about a third of the battery so that it can handle that. Then we have backup without feed-in and residential without feed-in. These are exactly the same as the previous two modes, but you do not feed power back to the grid. This is important in those areas that don't allow net metering. You may want to not feed back. That means you don't need to have a second meter if you're doing that. You should check with your utility company first before you follow that advice, but there's no reason we don't feed it back. It's also useful for the HECO environments. This is what you would be using there, where you can't feed back. So that's where you want to take that. And then you'd be using residential, self-consuming, no feedback. And then time of use. If you're doing arbitrage, charging the battery up at off-grid or under PV, off-peak, and then you'll feed back to the grid based upon time of use. That's where going back up, the high price duration in the system settings page, that determines when. And this time of use feedback determines how much and so on and so forth. Now, number 6 is an interesting one because it allows time of use feedback from the battery. So if you hear people say, oh, we want, net meter 2 where you've moved the time of use peak into the evening where there's no solar, so you can't feed back at peak hours. You can charge the batteries during the day and with PV, and then feed it back at 7 o'clock when your peak hours start. That way, you're actually getting benefit or doing self-consumption without drawing those high-cost kilowatt hours. So what do the different modes represent? Again, they represent how you use your power. The backup, your PV priority is you're going to feed the battery first. You're going to always keep the battery charged up. Notice it says keep the battery full and discharge only in case of power outage. So PV use and backup is going to be number 1, charge the battery. Number 2, feed the load. Number 3, send any that doesn't fall under those 2 categories back to the grid. For your load priority, you're going to feed your load. This is your critical load, the thing that's on the load side of your design. PV is going to power that load first. In backup mode, it'll be grid, and then the battery will be third. So if there's no PV, no grid, it'll go to battery. Charge from PV, yes. Charge from grid, yes. Feed grid from PV, but no from the battery. And then, like I said, 35–40% is where it shuts down. It's not an absolute 40%. We can go in that if you want later as a question, but it really isn't. And then off-grid, 0%. Residential. So here we change where the power comes from for your load. So in residential, PV use will prioritize your load first, your battery second. The grid will be your third source for power. Your load priority is how you're feeding power out. First will be PV, grid will be third, battery will be second. So again, you're self-consuming from the PV and battery before you use the grid for your powering your home. Charge from, yes, for the PV, of course, that's your cheapest power, but no from the grid. We don't charge the battery from the grid, we only charge it from PV. And then feed grid from the battery, from PV, yes, from battery, no. And battery depth of discharge is exactly the same. So now we have without feedback. You'll notice if we look over, there's nothing from the grid for PV use priority. We don't feed it back. And that's the big difference here. And that all the priorities beyond that are exactly the same, except feed grid from. You'll notice that that's no and no. We don't feed to the grid. And in time of use is essentially the same as what's referred up top. For backup, it's under low cost, it's exactly the same as that. Under high cost, it's the same as residential. So we try to avoid using power. It's a melding of the 2 backup and residential priorities and load priorities to accommodate varying prices in electricity. I think the only places that need this right now is California, Hawaii, and I think New York, but I'm not sure. But time of use is coming as PV gets more influence on the grid. And then, of course, under battery feed-in, this is where you actually do your arbitrage, where you charge the batteries and then feed it back from the batteries. Now, the big thing I need to point from here is notice the charge from changes. We do not charge from the grid when we're feeding back from the battery. Utilities seem to take great offense at charging your battery and then feeding it back at a higher price than what you charged it with. So we do not allow you to charge from the grid into that mode. This is really complex. There's a lot of things here. Take your time. Feel free to ask questions at the end. Feel free to send me email. We can go through it all. It takes a while to really let all of that sink in. But this flexibility is one of the reasons that the H5000 inverter is so powerful. This is incredibly powerful and flexible. So when we're bringing the system up, we've gone through the hardware install, we've gone through the modes, so you have an idea of what it is that we're going to do. Now we want to actually go through and start configuring the inverter, changing how that works so that it matches your current site. So the first thing we're going to do is configure for the battery type. So we're always going to set the battery type before turning on the battery, okay? That way, when the battery and the inverter come up for real, they know how to communicate. You're not turning things on and off, trying to make it work when the house is running. So you turn on all the power switches except the battery. So your PV switch, your grid switch, if you've got that, you turn that on so that you can run it. Turn on the inverter switch. That's the rocker switch on the side that we talk about. Wait until you hear the 3 beeps for the inverter, and this indicates that the system is running. It's running as a string inverter. There is no battery for this at this point. There's no critical load on either. That's not a power input, so you've left that off. The inverter will show error 63. It's simply saying that the battery is not connected. We expected that. You'll get a display that looks very much like what's shown here on the right-hand side. You've got some power. Of course, your numbers will change from this, but you've got power coming into the inverter, power going out to the grid, and potentially power going to your loads on the house, depending on whether you've turned that on or not. That's not critical. So this is what it's going to look like. We haven't set the time of day, so it's still 0. We're going to use the right arrow button twice to get to the system setting page. You recall this one from back at the beginning, where we've got backup mode, high price, so on and so forth. The default mode is backup. We'll go through that in a second. We're going to set the battery this time. Your high price duration, that defines the time of use, arbitrage hours. Time setting is just for today's current date and time. Multi-inverter is for stacking. If you have more than one inverter, you change that. And there are 4 predefined battery types. None is no battery is expected, as if you're running a string inverter. Lead acid, now that's what we call it, but it's used for all batteries without direct communication, whether that's LFP, whether that's LNMC, whether that's lead acid. If it does not communicate, we set it up as a lead acid battery. Number 3 is for Darfon's own B05 battery. It's our own 5 kilowatt hour LNMC battery. And so you would select battery type to 3, and that's what the default is here on this screen. And then for our H200 ESS, we've got our Panasonic battery, and you can set the battery type up for that. So we're going to be changing it to a lead acid battery type. This would be the appropriate battery type for the Fortress battery. So we select the right or left arrow key down to the circle I section, down at the bottom. Use the enter key and you'll be prompted to enter the password. And what you'll do to enter the password is a combination of enter and the arrow key. If you want to increase the number, you do the right arrow key. If you want to decrease the number, you use the left arrow key. So you'll go in, please enter the password. You'll hit right arrow key, enter, right arrow key, enter, right arrow key, and you'll come up with the password, which is 1111. So that now you've got that, and you follow the instructions. You hit enter, boom, that puts you inside. Use the arrow keys to select battery type and hit return. It'll come up with a little black arrow near multi-inverter single, and you hit right arrow and it'll go down to battery type. Hit return. You're now in, and you'll see the battery type 3 here in this example, flashing. You use the arrow key to single step through it until you get battery type 1, and then hit return. So if you look at this, battery type none, the default battery type should be none if you come from us. In this case, type 1 for the Fortress battery. You'll click 1 and it'll show you type 1. After saving the new battery type, the display will show changing new settings. This is the image on the bottom. Please do not shut down the system. You'll confuse it terribly bad. Don't turn it off at that point. Just like doing Microsoft updates, don't turn the power off unless it's a laptop. Once that's done, setting OK, press any key to exit. Notice the warning here. The system needs to restart before the setting will take effect. That is a manual operation. Press any key to turn the system down display, turn off the power with the rocker switch, wait a few seconds for the caps to drain down. It will not restart on its own. Turn on the battery. That's the switch on the right-hand side of the distribution box. And then you turn on the rocker switch, and now your battery type will be set as type 1. You're ready to go. Now, we're only going to go through the battery type, but the process to change any of our modes, whether it's backup mode to residential, to time of use, to changing the duration, time setting, all done the same way. The only difference is if you're in the top half of this box, your password is 9999. If you're in the bottom half, it's 1111 as we went through. But the process is exactly the same. So we've covered installing the hardware briefly, but we've gone through it. Configuring the hardware to the site, that's all the modes that we've been talking about. And we've set the battery type. Operational modes and date and time you can do, each one requires its own separate input. In fact, at the line level, so you change the operational mode from backup to residential, that's one entry. Then you'll save it. Then you'll have to go back in and change the date and time. New password install, so on. Each line has its own password. Now, this is the fun part. We're going to go through the advanced configuration. And again, this is going to be a brief overview because these are the things that typically get changed on installs. It's not going to be everything that we're going to go through as far as what we can go through, but it will be everything that is likely to need to be touched. So the first thing, we're going to download the hybrid AP application, install the software on your computer, connect the computer to your inverter. By the way, in real life, that takes about 2 minutes. Read your AP registers, that's about 3 seconds, and then learn the AP registers and how to use them to your advantage. So what you want to do is go to our website, darfonsolar.com, downloads, select, you'll see a display what's on the bottom here, and you'll select the software that down at the bottom. It says H5000 hybrid inverter software, and you'll get a single opportunity to download a file, which is H5000. Click on the icon that says download. If you've got your browser set up properly, it'll prompt you for the directory you want it to go into. That is going to be your working directory where you extract the zip files from it. And you'll be ready to go. There is no setup or install of the application. You're not going to run an install and have it change and put it on the desktop. It's not that complex. It's a very simple program. This is once you've extracted the zip files. These are the files and folders that'll come out of that single file that you downloaded. Your application is listed as an application there, Darfon Hybrid AP Tool. And that's what you're going to double click to launch. You're going to need, in addition, a USB A to B cable. Sorry, my bad there. And that'll have connections on the ends looking just like what you see here. There'll be a standard USB like what's on your computer or laptop, and then the older square one that allows that. You'll go through and remove the access cover. That's just 2 simple screws, number 2 screws on the side, and pull that cover off. And that will give you access to these 2 PC boards. Now, the only one you need access to is on the right-hand side. You see the USB cable plugged into the connector. It's very easy to see, very easy to get into. Launch the application. You'll be prompted for a password. Now we're going to have 2 sections to this. There's a user section. That's where your customer can, if they want to do this, they can do it. You can't make any changes. All you can do is read what the inverter is doing right now. It's kind of like a local in-depth monitoring system. So let's take a look at what that does. Oh, one other thing. In this case, there's no password. You actually have to click on the button login. But even when we go to the installer section, carriage return does not do an enter. You have to click on the button. So the first thing that you'll do is you see upper left-hand corner, there's the options button. You need to tell the application which COM port it's using to get to the USB cable. So you'll go to options, you'll see a window like this, you'll do the pull down menu for the port, select the COM port that the computer has given you, confirm that your baud rate is 9600, and click OK. Once you've done that, you'll see this button up here will say start. You'll click on that and you'll start getting information like this. It'll take a few seconds to start gathering information, but it'll be there. This tells you what your PV is doing, where the power is going, what your battery is doing, where the power is going, whether it's charging or discharging. and then back to the grid. All of the voltages for all of them, for load, grid, PV, are all listed here so you know exactly what's happening. Just like I said, a simple monitoring system that you can, should you're being attached, you can handle it. This is actually kind of nice for the installers. Once they got everything set up and confirmed, they can come into here, watch it for a few minutes, make sure everything is doing something that's reasonable and logical. Key point here is you can't do any damage from that. Now, at the installer level, this does require a password. It's installer, and this is case sensitive. Installer 1234. It's case sensitive. Note, it is not published in the manual. So this is the only place you're going to get that password. So again, you do the pull down menu when you launch the application, select installer, type in the password, click login. You'll do exactly the same thing as you did before, and you'll have to do it again if you've been in user mode and now you're going into installer mode. You'll have to restart the COM port so that it knows how to communicate to the inverter. Now, key point, you can make substantial changes to the way the H5000 works in the area that we're going into. You can make the system perform better or a lot worse depending on what you do here. Be aware of where you're going and what you're doing. This is not something that you want to be casual when you're in here. Fortunately, there's not much you need to do. So this is the screen that you'll come into. It's a blank screen. All of these red boxes are boxes that can be changed. You've also got values in them. You've also got a bunch of check marks, check boxes in the upper right-hand side. Once you get into this screen, the first thing you want to do is click a read of the parameters. If you know what you're going to be changing, case in point, it's a standard install, no Rule 21, you're just adapting the fields for the Fortress battery, you can look at on the right-hand side where it says battery shutdown voltage, battery float charging voltage, so on and so forth, and just read those. Or you can read all the parameters, and it'll fill in everything that you can change. In fact, everything, even if you can't change it. So once you read all parameters, it'll look something like this. So you've got your grid voltage, serial numbers, EEPROM values and numbers that are probably not important to you, and you probably should never ever change any of those. You've got some check boxes here. Here's your Rule 21 enable. If you're in an area that requires Rule 21, you'll want to come in and turn this on. PV parallel, that's for high voltage panels like thin film. That's going to be a separate topic later. PV off grid. If you're installing a system off grid, you need to come in here and turn that box on. If you're installing in Hawaii, you'll have HECO 1 or HECO 2, depending on your particular situation. And we're going to ignore these for right now. So that's Rule 21 and off grid. Those are the two most common reasons that people get into the AP registers. Those two right there. The next one is if you're buying someone's battery, in this case, Fortress battery, you're going to be able to define your charge current, which for the Fortress battery, you can leave alone. Your battery shutdown voltage, this is where the lower end of the battery voltage is, where it's at 0 or whatever percentage that you want to stop at, you define here. The battery float charging voltage, this is where it's going to take it to the peak. Now remember, this is being installed as a quote unquote lead acid. There's not necessarily a floating number for a lithium battery, but that's what we're using. And then the last point is battery reserve percent. So when you're in a grid tied mode, this will define where it comes down to before it stops discharging the battery under normal conditions and reserves this amount for backup off-grid conditions. Those are the three values: battery shutdown voltage, battery float voltage, and battery reserve percentage are the three that get changed the most, particularly if you're using a battery that isn't ours. In the case Fortress here, you'd need to get those numbers, which you need to set those up as, from Jing, and she's got all that. If you're changing it for Rule 21, these are your read-write for each section, as we went through earlier. These are your, sorry, I got involved with that screen, should have gone down through here. If you're changing Rule 21, you also need to change these values. You've got your volt var value, whether it can be a specified number. This allows the utility company to change things or to specify a unique number. You've also got aggressive or non-aggressive variants of that you can set as the default. Again, you should check with your local utility company to find out how they want those set. And then for your frequency support for the grid, you've got your start and end frequencies, how far up, how far down you can adjust the frequency to give good grid support. So when you're doing Rule 21, those are the things you're going to need to change. When you're adjusting to the battery, these are the things. You've got maximum, it's all here on the right-hand side. Note on the bottom right, voltage values are read as if there is a decimal point between the two rightmost digits. So 446 is 44.6 volts, 564 is 56.4 volts. That's how that's read. So if you're changing, let's say on your Fortress battery, and I don't know what those numbers are, I'm not making a claim here, that your maximum battery, your battery step-down voltage, it's currently 440, but let's say for the Fortress battery, you want it to be 45.2 volts. So you would edit that 446 with 4.2 or whatever the number is, and then hit write, this button here. That would then write those values out and set up the new charge rate. Again, you're going to need to restart the inverter for these to take effect. So after you've exited, everything's here. I always recommend doing a read of all parameters afterwards to confirm that you've seen that update. Exit this, restart the inverter, turn off the rocker switch, turn on the rocker switch, and you should have the new values. Okay, we have gone through this very quickly. My statement has been this should be a one-day class, not a 30-minute, and I've gone too long, 30-minute webinar, but we've installed and configured the H5001. You've done all the things a typical installation would need to have done. Off-grid is handled, Rule 21, date, time, battery, mode of operation. You can figure out how to do that. Total time to do all this on a real site is measured in a couple of minutes if you know what to do. None of it can be done at the factory because it's site specific. So it's up to the installers to know what to do and how to do it.
Okay,
Yay!
Brian, really appreciate it.
Wow. Sorry about that.
Thank you for that. It's really good that you cover all those points, and those are the things that also matter to installers. Quick side note regarding the battery parameters that are it's on our installation manual. Good, and I know it's a lot of information, but no worries. Here's Brian, my contact information, and you guys feel free to reach out if you have a question. We do also, I'm going to take a look at what questions that we have. People are going to post that question here. Good. So let's see the question section and people post the question here. Okay, we got people ask questions. Actually, a lot of questions. Just give us a second. Let's put it out. All right, I'm going to read the question. If I be able to answer well, if not, then I will ask you to answer, okay?
Sure, no problem.
Good. Yes, we will provide the presentation. We will email to all of you, so no worries. Good. And next question is from John. The data interface for data analytics for maintenance monitoring. I think this is actually for you, Brian.
Yeah. So the monitoring, okay, yes, there is remote monitoring, and yes, it will be available. We're waiting for, things are changing for us in this regard. So in the past, we've only had one-way monitoring. In other words, we could get information and upload it to the portal. With this application, with this inverter, that's not going to be the case. We need a two-way communication. We're going to, the ability to configure this inverter is going to be handled through the monitoring. So you can have your engineer at the site or the designer at the site. Once it's up and running, your installer turns it on, boom, you're up and running. Your installer doesn't have to know how to configure, your engineer can do that. That's all going to be handled remotely. So we need a new data logger that allows bidirectional communication. That should be here end of August for me to start doing evaluation on. So it should be available shortly after that. You can put our existing data logger in and tie it up and start working, but it will only read information. It will not write to it. And we are in the process of updating our portals, so it may be up and maybe down over the next few weeks. But it is there. It will be available. Bidirectional communication, by the way, is required for Rule 21, so that's why we're forcing this change as quickly as possible. It's going to be required from us by Q1 next year. So
good. And I have Emma asking about the pricing for the micro inverters. So Emma, if you can, send an email to the Brian,
yeah, send it directly to me.
That'll be great. Yes, and Brian will allocate based on where you are to the, Darfon's distribution partner.
Or yeah, or you can go straight to Jing and get her pricing for it, because you can buy from her as well.
Good, appreciate that, Brian. So next is from John here. Can that computer communicate first the setting remotely, like from a central office, for technical engineers to set, or it's only at local site?
Yeah, that's coming very shortly. Like I said, when the bidirectional data logger comes in, be able to turn the power on, turn the system on at install time, and the engineer back in the office will be able to configure that. That is coming. We have to wait for the hardware. It's not quite finished yet. So, but that's on its way.
Good. The next question is for Mark. What's the highest charging voltage that a Darfon can be set or programmed, 60 volts or 64 volts?
58.
58 volts.
Yeah. Good. This question is asked a lot. There are a lot of batteries out there that charge at about 60 volts. We've taken this under consideration because we want to satisfy as many different batteries as possible. And that would require a hardware change on our part, and that makes it really tough because we'd have to go through UL again and everything else. So at this point, 58 volts is the peak charge voltage.
Okay. Next question from Ben. Can a Wi-Fi adapter be connected to USB port so owner can monitoring via Wi-Fi device?
That's going to be the data logger's responsibility when it comes out. It'll have internet, it'll have cellular and Wi-Fi connectivity in the data logger. So when that comes up, then we'll have the ability to do everything you're asking. At this point in time, you can put our current data logger, but I really think that that's not a prudent thing to do because it doesn't have bidirectional communication. So I would just either hold off or be willing to swap out the data logger when the time comes.
Okay. Then the question for Mark here, does the Darfon have any communication with the battery pack or BMS?
That's a question of the battery pack. We provide communication. In the case of the Fortress battery, it doesn't need it. And to be honest with you, Most LFP batteries don't have communication. It's not required for the battery. The reason you have communication with LNMC is because the cell itself is subject to thermal runaway. So you have to keep track very carefully what your temperature is, very carefully what your charge state is, because if the cells get out of balance and you're forcing a charge on one that's already charged, you can cause problems. That doesn't exist with an LFP battery. So many LFP batteries are designed without communication. It's as simple as a lead acid battery. So if you're using, say, our H200 and you're using our Panasonic battery, that has full communication. You can see all of the cell temperatures, all the cell voltages. The same with our BO5 battery, the 5 kilowatt hour battery that we sell. Full communication. Again, LNMC. So now that gives you all the information you want. It is more accurate. State of charge with an LFP battery, if you're just monitoring from voltage, is only accurate to within about 10% because the voltage is not a good representation of what the current state of charge is. But other than that, that's the only thing you're giving up. I hope that answers your question.
Yeah. That's also the reason that we have come up with the generation 2 with the monitoring on the battery itself, that it can also give you a more accurate information. So then I have also a question from Emma. Emma, if you see my screen, my email address is here. Is I can repeat that: JINGY@fortresspower.com. It's actually shown on my screen, and you're welcome to send me the email. So then I have also a question from Joe. What's the casing made of? My concern is a possible corrosion of the battery casing to be strong enough in harsh environments such as near the ocean with a high humidity. It's iron case. Frankly speaking, it's also coated. I don't foresee there's an issue, with the corrosion or the humid. Think about it. Those are the battery also from automotive, and you're parking the car. It's really even, in the outdoor condition. So the environment request is even higher for if you put it in the ocean, in the house near the ocean.
Yeah. So with regard to the inverter, it is powder coated, which is a very good deterrent against corrosion. The PC boards internally are all coated, so they're protected. However, we don't think it is prudent to install this on a beach somewhere. It is an indoor rated case. It's a NEMA 1. If you have it in your garage, in an equipment room, something like that, I don't think you're going to have any problems. If you have it outdoors in Jamaica, you're going to, I'm not going to make any massive guarantees. I mean, it should be fine as long as it's protected from direct contact. I say should be. We've not experienced anything. It's designed appropriately, so it shouldn't. Anything made by man will corrode given enough time. Again, I wouldn't recommend putting it on the ocean, on the beach, but it should be fine in an installation where it's intended. And we install in Taiwan, which is an island. We install in Guam, which is an island with a lot of salt. We install in the Caribbean. We've got a lot of systems installed there. We've had no problems of any kind with it.
Good. Further questions? It looks like that's all the questions we have, and Brian, I truly appreciate that you take time. Oh, I do have here from Joe. Let's just wait a second. Okay, Joe mentioned that he's in Guatemala, FSM. Apology, I don't know what that stands for, and Paula.
Palau,
Joe, do you have any questions?
It's actually Guam and Palau. And we're actually working on a large installation potential in Guam right now. So I don't know that it's going to work or not, but we're working on it.
Okay.
Palau, it's only 120 degrees with 99% humidity. Yeah, you can have it. No, thank you.
Good. Okay, we do also, just before we go, we would truly appreciate your time. So we have a promo code. If you put in Go Green, then sign up as authorized dealer, we'll give you $250 discount from Fortress to appreciate your time. And again, any questions, feel free to email us or call us. We'll be very happy, to help you. Okay.
Thank you so much. I appreciate your attendance.
Thank you. Bye.